Today we are going to learn about Boosting Demystified, harnessing XGBoost's power. In this video, we will delve into the intricacies of XGBoost, understand why it excels in predictive accuracy, and master its implementation in Python. You will gain practical skills to apply XGBoost efficiently in solving complex predictive problems.
Welcome to our exploration of Boosting Demystified, harnessing XGBoost's power. Boosting is a powerful ensemble learning technique that combines the performance of many weak learners to create a strong learner. XGBoost, or extreme gradient boosting, is one of the most efficient and effective implementations of this concept. It's known for its speed and performance and is pivotal in many competitive machine learning challenges. In this video, we will cover the foundational concepts of boosting, explore why XGBoost is a standout tool for achieving high predictive accuracy, and provide practical insights into its implementation. We'll also look into XGBoost's hyperparameters, manage overfitting, understand feature importance, and compare it with other boosting techniques. Lastly, we'll share real-world case studies where XGBoost has made significant impacts. Let's dive in. Boosting is a machine learning ensemble technique that aims to create a strong classifier from a number of weak classifiers. The core idea is to train classifiers sequentially, each trying to correct the errors of its predecessor. Unlike bagging, which builds models independently, boosting works by adjusting the weights of previous models' predictions to focus more on the difficult cases. This process involves incremental training, where each new model attempts to improve upon the mistakes of the previous models. It's particularly useful in improving model accuracy, making it a staple in competitive machine learning. Boosting is not just about training models but is an iterative process where the model learns from the training data in successive rounds. Each round aims to reduce the errors from the earlier rounds, ultimately leading to a robust predictive model. This approach is especially beneficial in scenarios where initial models are weak but can be significantly improved with subsequent iterations. Understanding this foundational concept is crucial before diving into XGBoost, which optimizes this technique for speed and performance.
XGBoost stands out in the machine learning community for its exceptional predictive accuracy and performance. One of its primary advantages is its speed, which is achieved through parallel processing and efficient memory usage. XGBoost can handle missing data automatically, which is a significant advantage in real-world datasets where missing values are common. The algorithm incorporates regularization parameters, which help in preventing overfitting, a common issue in machine learning models. Furthermore, XGBoost uses a novel tree pruning technique called max depth, which allows the model to avoid overfitting by limiting the depth of the trees. This technique ensures that the trees are not grown beyond a certain limit, maintaining a balance between bias and variance. Additionally, XGBoost's ability to handle different types of data and its flexibility in tuning hyperparameters make it a preferred choice for data scientists and machine learning practitioners. It is designed to be scalable across different tasks, including regression, classification, ranking, and user-defined prediction problems. By understanding these features, you will appreciate why XGBoost is a go-to solution for achieving high predictive accuracy in complex predictive tasks. Setting up XGBoost in Python is straightforward, yet it sets the foundation for building robust models. The first step is to install the XGBoost library, which can be done using pip with the command pip installs boost. Once installed, the next step is to import the necessary libraries, which typically include XGBoost, pandas, and scikit-learn for data manipulation and model evaluation. After setting up the environment, you need to load your dataset. This can be achieved using pandas to read data from CSV files or other data sources. With the data loaded, the next step is to define your XGBoost model. This involves specifying the model's parameters and deciding on the type of task, such as regression or classification. Once the model is defined, it's time to train it using the training dataset. This process typically involves splitting your data into training and testing sets to evaluate the model's performance. Finally, after training the model, you can evaluate its performance using metrics such as accuracy, precision, recall, or mean squared error, depending on the task. By following these steps, you'll have a working XGBoost model ready to tackle your predictive problems.
XGBoost offers a wide range of hyperparameters that can be tuned to optimize model performance. Understanding these hyperparameters is crucial for maximizing the accuracy and efficiency of your models. Some key hyperparameters include learning_rate, max_depth, and estimators, subsample, and co-sample by tree. The learning_rate determines the step size at each iteration while moving towards a minimum of the loss function. Max_depth controls the maximum depth of the trees, impacting the model's complexity and potential overfitting. And estimators refers to the number of boosting rounds, while subsample and co-sample by tree control the fraction of samples and features to be used for training each tree, respectively. Parameter tuning is often done using methods like grid search, where different combinations of hyperparameters are tried out to find the best performing set. This process can be computationally intensive, but it's essential for optimizing the model's predictive performance. By carefully selecting and adjusting these parameters, you can significantly enhance the accuracy and efficiency of your XGBoost models. Overfitting is a common issue in machine learning where a model performs well on training data but poorly on unseen data. In boosting models like XGBoost, managing overfitting is crucial to maintain predictive accuracy. One effective way to combat overfitting is through regularization techniques, which add a penalty for complexity to the model's loss function. XGBoost provides regularization parameters such as lambda and alpha to control L2 and L1 regularization, respectively. Another method is cross-validation, which involves dividing the data into multiple subsets and training the model on different combinations of these subsets to ensure it generalizes well. Additionally, reducing the model's complexity by limiting tree depth and the number of boosting rounds can help prevent overfitting. It's essential to strike a balance between bias and variance. Too much complexity can lead to overfitting, while too little can lead to underfitting. By understanding and applying these techniques, you can develop XGBoost models that maintain high predictive accuracy without succumbing to overfitting. Feature importance is a critical aspect of model interpretation, providing insights into which features have the most significant impact on predictions. XGBoost offers several methods to evaluate feature importance, including gain, cover, and frequency. Gain measures the contribution brought by a feature to the model, cover measures the number of observations related to a feature, and frequency counts how often a feature is used in trees. Interpreting these results can help identify which features contribute most to the model's accuracy, allowing for more informed decision-making. Understanding feature importance can also guide the feature selection process, helping to reduce dimensionality by focusing on the most impactful features. By analyzing feature importance, you can gain deeper insights into your model's behavior and ensure that you're using the most relevant data for predictions. This understanding can lead to enhanced model performance, as well as a better grasp of the underlying patterns and relationships in the data. Boosting is a family of ensemble learning techniques, and XGBoost is just one of its many implementations. Other popular boosting techniques include AdaBoost and gradient boosting. AdaBoost, short for adaptive boosting, is one of the earliest boosting algorithms and focuses on improving the weights of misclassified instances. Gradient boosting, on the other hand, builds models sequentially by optimizing a loss function. While all these techniques aim to improve predictive performance, XGBoost offers several advantages. Unlike AdaBoost, XGBoost includes regularization, which helps prevent overfitting. Compared to gradient boosting, XGBoost is often faster due to its parallel processing capabilities and efficient handling of large datasets. The performance differences among these techniques depend on the specific use case scenarios and dataset characteristics. XGBoost is generally preferred for large datasets and complex problems where speed and accuracy are critical. By understanding these differences, you can make more informed decisions about which boosting technique to apply in different situations.
XGBoost has been widely adopted in various industries due to its excellent performance and versatility. In finance, it's used for risk assessment, fraud detection, and algorithmic trading. In healthcare, XGBoost assists in disease prediction and patient diagnosis by analyzing complex datasets with high accuracy. The retail industry leverages XGBoost for customer segmentation, demand forecasting, and recommendation systems. These real-world applications demonstrate XGBoost's impact on predictive tasks, where it consistently delivers high accuracy and efficiency. Many success stories highlight how XGBoost has transformed data-driven decision-making processes, leading to significant improvements in operational efficiency and customer satisfaction. Lessons learned from these case studies emphasize the importance of understanding data characteristics and selecting appropriate hyperparameters for optimal results. By exploring these scenarios, you'll gain insights into how XGBoost can be applied across various domains to solve complex predictive problems and drive meaningful outcomes. As machine learning continues to evolve, XGBoost remains at the forefront of innovation and development. Emerging trends in the field point towards further optimization of XGBoost's algorithms to enhance speed and accuracy. The integration of XGBoost with AI technologies, such as deep learning, is another area of development, expanding its applicability to even more complex problems. The open source community plays a significant role in XGBoost's evolution, with continuous contributions and improvements being made to the library. Future advancements may include more intuitive interfaces, better support for distributed computing, and enhanced capabilities for handling diverse data types. By staying informed about these trends, you can better prepare for the future of machine learning and leverage XGBoost's full potential in your predictive tasks. The continued growth and development of XGBoost ensure that it will remain a critical tool in the data scientist's toolkit for years to come. As we conclude our deep dive into Boosting Demystified, harnessing XGBoost's power, let's recap the key points we've covered. We explored the basics of boosting and why XGBoost stands out for its speed, accuracy, and versatility. We walked through setting up XGBoost in Python, explored hyperparameter tuning, and learned how to manage overfitting. We also discussed feature importance and compared XGBoost with other boosting techniques, supported by real-world case studies. The practical skills you've gained here empower you to apply XGBoost effectively in solving complex predictive problems. Looking forward, consider exploring more advanced topics, such as integrating XGBoost with other machine learning frameworks. Thank you for joining us on this learning journey. Embrace the power of XGBoost to elevate your machine learning projects to new heights.